Right, the second type of plate boundary we're going to look at is called a conservative plate boundary. This is when two plate boundaries move past each other. They can move past each other in the same direction, but at different speeds, or they can move past each other in the opposite direction. It doesn't really matter, but the principle is they're moving past each other. So I'm going to try and illustrate this. So I'm going to try and draw a plate. The first plate and then the second plate. And I'm going to put them side by side. I'm going to make this three-dimensional. And I'm going to put the plates, in this case, moving in the same direction, but they're moving faster. So one is moving this way, this one's also moving that way, but at different speeds. What happens is that along the plate boundary, they don't slide smoothly past each other. They stick. But at some point, when things actually become unstuck, there's a sudden movement or a jolt in the ground surface, which releases seismic energy in the form of an earthquake. On this plate boundary, we don't get volcanoes because no magma from within the Earth's mantle can actually get to the surface. But the plates will stick and the plates will move in the same or the opposite direction and release this type of energy. So I'm now going to put the labels on it for you. So here are the labels on the diagram now. So you've got, in this case, two continental plates moving past each other at different speeds. The plates get stuck because of friction. They stick together. But as the plates are trying to move, eventually that pressure is released and the plates suddenly jolt, move forward quickly, releasing the seismic energy in the form of an earthquake. Now that earthquake on land would be an earthquake. If that earthquake occurred in the sea and the plates not only moved this way but moved a little bit up and down, then that would create a tsunami. A really good example of this is the San Andreas Fault in California. This line here is the fault line, and the plates actually have numerous fault lines in California, and so the plates actually move as the different fault lines move. So we end up with like some small earthquakes and occasionally very big earthquakes.